Good afternoon. We are going to take notes on the first day of Unit 11, which is our trigonometry unit. So it's Trig point 1. The notes are going to be numbered by decimals in the unit rather than sections in the book because we're going to be picking and choosing from various sections in Chapter 4. So you might want to pause the video, take a second to put in the title and these thumbnails. We're not actually going to be graphing, but we will be doing 5 little thumbnails here. So you don't have to use graph paper, but you can if you want. So pause the video and kind of get ready for notes today. Okay, so Roman numeral 1 is converting between degrees and radians. Up until now, most likely you only knew about degrees and not radians because degrees are what we use in everyday language about angles. But there are many things in science and in math that radians must be used. There are certain calculations that degrees simply won't work. So we have to be able to go between degrees and radians at will, depending on what we're going to be doing. So we're going to draw a little graph here and do a comparison between degrees and radians. Okay, so this is A. This is the visual basics. All right, so first thing you need to know is that the initial side of any angle that you measure in pre-calculus is here. This is your 0 mark. And again, we call this the initial side of the angle. It's the one that stays in place. It doesn't move. So in fact, to show all the different measures we're going to, the initial side is always pointing directly right. Directly right is your 0 degree point. So down below here, we're going to list the measure in degrees, and we're going to list the measure in radians, because you need to have an idea of how they look in comparison to each other so that the conversions are easier to learn. Okay, so if your angle is pointing directly right, just like the initial side, that would be 0 degrees. Radians, it would also be 0. Now, it's going to mess with your head a little bit, but radians does not have a symbol like degrees does. So pretty much if it's an angle, you just don't put the degree symbol on it, and the default is radians. If it helps in the beginning, you might just put, an abbreviation like rads for radians so that you know what you're looking at. All right, so if the initial side is pointing to the right, what we call the terminal side is the second side of the angle, and it's the one that moves. So here we have another angle, and this is the moving one, and it's the terminal side. So we have initial side and we have a terminal side. When the angle rotates from 0 that direction, it's a positive angle. When it rotates in the opposite direction, it is a negative angle. And they all are measured from direct right, which is 0 degrees. So the measure between our initial and our terminal side on this example is actually 90 degrees. So in degrees, 90 degrees. In radians, pi over 2. Pi over 2. Okay, so continuing on. If our terminal side, so the angle swings around, and our terminal side is going directly to the left from the initial side, well, in degrees, you know that that is 180. We learned that in geometry. In radians, it is pi radians. So half of a circle is pi. Okay, continuing on. If your terminal side swings all the way to where it's pointing straight down, that would be 270 degrees. In radians, that would be 3 pi over 2, or 1.5 pi radians. If your angle goes all the way around and it stops where it started, an entire circle measurement is 360 degrees, and in radians, it is 2 pi. So that gives you kind of an idea of how degrees and radians compare to each other. Radians have a lot of fractions. They have pi in them, so they're automatically irrational. But again, lots of formulas work with radians that don't work with degrees. Okay, so that's our visual basics. So we're going to go on to part B. We're going to do conversions between the two. And to do that, we're going to use unit analysis, which we learn in Algebra 2. So in order to do a conversion with unit analysis, you need a conversion fraction. And so we need something that we can use to get the units to cancel out. So the easiest conversion fraction or ratio to use is the fact that pi radians equals 180 degrees. So that's the one we use most commonly. You could use 2 pi radians equals 360 degrees, but that's just twice as big, so there really isn't much reason to go twice as big unless it makes something else convenient. All right, example number 1. We're going to take 20 degrees and we're going to convert it to radians. So just like regular unit analysis, write what you have over 1, and then you're going to multiply it by the conversion fraction flipped by whichever direction will cause degrees to cancel out. So in this case, I'm going to put the 180 degrees on the bottom, and for right now, I'm going to go ahead and write radians. I'll stop doing that after a while when we get used to it, but pi radians over 180 degrees. So in unit analysis, if you have a unit on top and a unit on bottom, they divide out. So the degrees actually divide out, and all we have left is radians. 20 pi over 180 we can do the trick with the zeros. I have 2 pi over 18, which is pi over 9 radians. So that is your converted angle measure. All right, let's do another one. Example 2. We're going to go the other way. We're going to do pi over 3 radians, and we're going to convert that to degree measure. Okay, so when you write your pi over 3, you can put your radians on top because that's where it is, all over 3. We're going to multiply by the conversion. Now this time I want radians to cancel. So on my conversion fraction, the pi radians is going to go on the bottom. The 180 degrees will go on the top. Radians divide out radians, and better than that, pi divides out pi. So what we have left is 180 degrees divided by 3, which is 60 degrees. Now you've done conversions before, just not with radians and degrees. Okay, Roman numeral 2. Degrees are good units of measurement, but there are times when we need more exact measurement. Things like ships and planes that are measuring where they're going by degrees of turning or degree of angle, we need something that's a little bit more complicated. So we have what's called DMS, and I just realized I put DSM in the title. It should be DMS. Good grief. There we go. DMS notation means degree, minute, second notation. We say DMS for short. But what it does is it allows us to be a lot more exact without going fractional on our angles. So to do DMS conversion, you need to know the conversion ratios. So here we go. 1 degree, and I'm going to write the word and the symbol, is equal to what we call 60 minutes. And the symbol for minutes, we usually just make it look like that. Just like a prime notation, it's actually more like this with a round tip and then a pointy end. It's very, very old notation, like ancient Sumerian notation. Minutes, so 1 minute is equal to 60 seconds, which is a double prime symbol. You go, wait a second. Minutes and seconds, that sounds like time. It does. The Sumerians actually came up with our 60-minute hour, and they really liked the number 60 and 360, 360 days in a year. So yes, there is some similarity between that and time. All right, let me flip the page here. Okay, so we're going to do some conversions. So for example, we are going to convert 37.425 degrees to degree, minute, second notation. Now, when you go to degree, minute, second notation, they should be all whole numbers. No decimals. Otherwise, you haven't done it correctly. By the way, to input an angle in degrees into your calculator, degree, minute, second notation doesn't go into your grapher. You have to convert it back to degrees in decimal form and then enter it to do calculations. All right, so here's how you attack this. You start by taking the decimal part only, which is in degrees, and you're going to change that to minutes. Then, number 2, you take the decimal part only of the minutes and you convert it to seconds. It's a pretty easy process. So looking at our number, 37.425, we have 37 degrees. We're going to keep that because that's the first part of the degree notation, so that's good. But we need to take the 0.425 degrees and convert it. And we're going to use unit analysis for this. So put it over 1, and then you need your conversion fraction. There's 60 minutes in a degree. So I'm going to put 60 minutes on top and 1 degree on the bottom so that degrees and degrees cancel. When you multiply 0.425 times 60, you end up with 25.5 minutes. So what we're going to do is we're going to keep the 25 minutes and we're going to peel off the decimal again, the 0.5, which is in minutes. Put it over 1. We're going to convert that to seconds. So we know there are 60 seconds in a minute. So we're going to go 60 seconds on top, 1 minute on bottom. That way our minutes cancel, and for units, all we have left is seconds. And this ends up being 30 seconds. So that is the third piece that we need. If this last one turns out to be a decimal, I think most of them are made so they turn out nice and whole numbers. But if that turns out to a decimal, you're going to have to round it because there are no decimals in degree, minute, second notation. Okay, so your answer, you put these just back to back from greatest to smallest. So our answer is 37 degrees, 25 minutes, 30 seconds. So again, you pull the whole number off, use the decimal, convert from degrees to minutes, keep the whole number for minutes, pull off the decimal, convert from minutes to seconds, and you have your notation. All right, we're going to go the other way now. So example 2, we are going to convert 42 degrees, 24 minutes, 36 seconds, and we're going to convert this to degrees. And because it has minutes and seconds, you're going to have decimals in this. It's not possible to not have decimals because you have to have something that does the smaller measurements of minutes and seconds. Okay, so basically what you're going to do is you're going to convert all pieces to degrees. Then add. Pretty simple. So obviously 42 degrees is good to go. It's already in degrees. So we need to work on the 24 minutes. So you're going to put 24 minutes over 1. I want it to go to degrees, and I know there are 60 minutes in a degree. So I'm going to put 1 degree over 60 minutes so that minutes and minutes cancel out, and all I have left is degrees. And this ends up being 0.4 degrees. Okay, we're going to keep that part. Now we're going to do the 36 seconds. So 36 seconds over 1. We're going to go from seconds to minutes. So 60 seconds goes on the bottom, 1 minute goes on the top. Now we're in minutes. Now we need to go from minutes to degrees. There are 60 minutes in 1 degree. So the minutes cancel out, and the only units left on top are degrees. So we have 36 degrees over 60 times 60, which ends up being 0.01 degrees. So we converted the minutes, we converted the seconds. Now we're going to add those together. So 42 degrees plus 0.4 degrees plus 0.01 degrees is 42.41 degrees. And that would be your answer. All right, so that's pretty much what we're going to be practicing, is how to graph basic angles in degree notation and radian notation, how to convert between degrees and radians, and how to use degree, minute, second notation. All right, have a good afternoon.